All right, one thing I haven't talked to you a lot about yet, but I need to, is what is this NOx? We saw that when we were looking at our emissions, and we saw that one of the things we're checking for is NOx. NOx stands for nitrogen oxides. So you put an X there because X can be 1 or 2. So we're talking about, when we say NOx, we're just talking about the oxides of nitrogen, which are not the oxides that we care about are nitric oxide or nitrogen monoxide and nitrogen dioxide. Okay, those are the two oxides that we care about. And you saw early on when we were looking at the beginning, I think, of lecture 10, when we were looking at the combustion reaction in general, we saw a combustion reaction between nitrogen, okay, I'm going to put it up here. Nitrogen plus oxygen gave nitric oxide or nitrogen monoxide, and to balance it, we had to put a 2 in front of it. All right, so that's strange. If we live in an environment where most of our air is nitrogen and oxygen, and this is a chemical equation that can occur, a chemical change that occur, why don't we live in an environment that's all nitric oxide? Well, the reason why is this reaction does not go very easily. It only goes in the presence, when it's really, really hot, in the presence of a lot of heat. And so, where is that going to happen? Well, that happens in a combustion engine. Air is being drawn into the engine, and the fuel is combusting. And since the air has both oxygen and nitrogen, it's very hot when it combusts. And so you can make a small amount. You don't make a lot because it takes a lot of heat for this to go, but you do make a small amount of nitric oxide or nitrogen monoxide. So it doesn't just happen, outside. There has to be a lot of heat. And even at that, it just creates a small amount of it. It's not like all the nitrogen and oxygen present is going to convert to nitric oxide. Another place that this is formed in the environment naturally is by lightning strikes. Because by a lightning strike, it's really hot, and there's nitrogen and oxygen present, and you'll get a small amount of nitrogen monoxide formed there as well. We call this a primary pollutant, nitrogen monoxide, because it's first. It is a pollutant that comes from your tailpipe. It's hot enough to occur. Very small amounts of it come out, but it's called a primary pollutant. That nitrogen dioxide is actually more poisonous and dangerous than nitrogen monoxide. It's considered a secondary pollutant, okay? After the nitrogen monoxide is formed, and here's a reaction showing it. This is nitrogen monoxide, oxygen gives nitrogen dioxide, okay? Or in other words, 2NO plus O2 gives 2NO2, okay? That's that reaction. So that's a secondary pollutant, and that will occur when again, this one, because this will only occur if you have decent enough, high enough concentrations of nitric monoxide, which you don't really have under normal circumstances. A lot of nitrogen monoxide coming out of the tailpipe. So this is the reaction that will occur, but it occurs slowly, except in the case when you have VOCs present at the same time, okay? The presence of the volatile organic compounds increases the production of nitrogen dioxide from nitrogen monoxide, all right? So that's the problem with the tailpipe. That's why we need to limit the amount of VOCs that are coming out of the tailpipe, because when the VOCs are coming out at the same time that you're producing the nitrogen monoxide, that's where we can have actually this NO2 formed, okay? This reaction that I showed you previously is naturally very, very slow. It doesn't really contribute to the production of nitrogen dioxide as a pollutant. The problem is, in the presence of these VOCs, we always have a little bit of, this is it's an ionized water, actually. It's a hydroxyl free radical. This little dot right here is indicating a very, very reactive electron. We'll talk more about this later on, but for now, just take my word for it, that this is a very reactive free radical that's found in nature The VOCs would come from your car. Together they produce something else. We'll just call it A because it's too complicated. It's another hydrocarbon that's very reactive. Okay, we're just calling it A because we don't need to get into the details of what it is. But they are the result of the free radical reacting with the volatile organic compound. That hydrocarbon A will then react with oxygen. The oxygen will combine with the A to give another nasty, we don't care what it is exactly, it's just a nasty reactive compound that then will in turn, this nasty, which came from the original VOC with the hydroxide, then with oxygen, nasty VOC, will then react with the nitrogen monoxide that came from the car to give, this nitrogen monoxide is actually going to pick a reactive oxygen off of this to give the NO2. Okay, so that's the major source of NO2 as a pollutant out of the car. It's called a secondary pollutants, because it is the result of a second reaction. The primary source of nitrogen monoxide is just hot place, nitrogen, oxygen present. All right, nitrogen, oxygen in the hot place will make a little bit of nitrogen monoxide. The nitrogen monoxide then, in the presence of the VOC, which has reacted with the hydroxyl and the oxygen in the environment, will then produce the NO2. Okay, so it's sort of a complicated series of events, but the bottom line is that it's the VOC and the NO present together out your tailpipe to give you the NO2. Now the problem with NO2 is it's very toxic. It itself, it's a small molecule, and when you breathe it in, it can interfere with some other natural metabolic processes, okay, and make you very, very sick. It contributes to acid rain if you don't breathe it in, just by itself in the water vapor in the air. It combines to form nitric acid, HNO3. We'll talk about this later next semester. I'm just telling you, it's nasty. A nitric acid is a strong acid, and you know, like for example, the one strong acid that you're probably familiar with is hydrochloric acid. It will burn your skin. Nitric acid is the same strength as hydrochloric acid. If you breathe in, even if you breathe in nitrogen dioxide and it combines with the water in your lungs, together it can form the nitric acid, and it can scar the inside of your lungs where it touches the tissue. So it's nasty stuff to be avoided for sure. And so it's what contributes to smog. It gives it that kind of brownish, it's got like a brownish color. It can just destroy, lead to breaking down rubber on the tires, and it causes great problems for people who have already compromised lungs, because the carbon monoxide, also, but like this doesn't stick to the hemoglobin like the carbon monoxide, but it does cause damage to your lungs, your lung tissue, and can cause your lungs not to work as well, and cause you to have like fluid in your nose, in your lungs, as it's trying to counteract the acid, causing coughing. It can exacerbate asthma. I mean, just go on and on and on. It's nasty stuff. All right, so we want to avoid it.